Hello and good evening, my dear student. All right. So, hello and welcome back to Buddy Education, all my dear student. I hope you all are doing good. And in the last lecture, we have finished our chapter number 1, which was matter in our surrounding, with the discussion of few questions. So, I hope you all are studying well and solving the question, revising the lectures. So today we are going forward with our second chapter, which is matter around us pure, right? So before I'll start the today's lecture, I just want to know from your side whether my voice is clear and you can see me clearly. So just quickly give me a thumbs up on chat box that yes ma'am, your voice is clearly audible. So just give me a thumbs up in chat box, then we can start our class today. All right, I'll check from my end as well. Hello, Amit. Good evening. So quickly give me a thumbs up that my voice is clearly audible to all of you. I'm also trying to check from my end. Okay.
Hello Amit, good evening.
Yes. The voice is clear from my side. All right. So I get the thumbs up from your side as well. So I hope everything is good to go. Now we can start the class. So all right student, I hope you all are studying the chapter thoroughly and also solving the question that we have discussed in the class as well. Also I have shared the PDF of the lectures and the questions on our Telegram channel. So those who are new and those who already joined the series and watching the series since a long time, I request you all to go to the Telegram channel and see the questions from there and solve those questions, because in your half yearly examination question will surely come from them, right? Also the question that I have discussed in the lecture only. So I hope we are good to go, and today we are going to start with the another chapter, is matter around us pure. In this, as the chapter says, that whether the matter that we have studied in the lecture 1 or the chapter 1 is that pure, in which category we are going to put, right? So if you guys remember that in the initial of the chapter number 1, we have discussed about the categorization of matter into two types. So what were they? I told you that matter can be classified according to two properties, right? So if you going to classify any matter, so here let me just write for you. So if you classify matter, then it can be classified according to two properties. First one was the physical properties. So according to its physical property, we divided the matter into 5 classes, which was solid, liquid, gas, plasma and BEC. And I have told you that total we have 22 states of matter, right? So we discussed all about the physical property or the physical classification of matter in the lecture number or the chapter number 1, right? Now it's turn, because there we have just discussed, but did not discuss about the chemical classification of the matter in detail. I have just given you the idea about it, that matter can also be classified into other format on the basis of its chemical property or the chemical character, right? So now we are going to discuss about the chemical classification of the matter. In the first chapter we have discussed about the physical properties. So we are done with this. Now let's focus on the other classification. So before I will start this lecture, I just want to know the answer of few questions. So I will flash some question on the screen. You just think about it and let me know what is your point of view about those questions. All right. So we know that matter is classified into two categories. We are focusing on the physical property of the matter, right? Let me erase it for you. Now you have to think about few questions. So the first thing, that in the last lecture we have discussed about solid, liquid and gas. Then, but how do they exist in nature? So we have seen solid substances, liquid substances and gaseous substances. But if we talk about our journal life, our daily life, the matter in our surroundings, then how do they exist in our real life? You have to think about it. Then do they exist as pure substance? Are they pure? Solid, the solid substance we are talking about, the liquid and the gaseous substances. Then, or they exist as a mixture of substance. So these are the questions that I want to know from your side, that what is your opinion that the matter we are seeing in our daily life, is it pure or the mixture of many substances? So you have to think about it and comment in the chat box that what are your point of view about it, about the question that I have asked. All right. So let's just understand this, all the answer of these question in this chapter, which is known as is matter around us pure. So now we are questioning to in the chapter only, that is matter, the whatever matter we are seeing, whether solid, liquid or gaseous, are they pure or something else? So we need to understand the nature of matter, that how they do exist in our daily life or in our atmosphere. So to understand that, first we should know that matter is made up of tiny particles. So we know, we have discussed and we talked a lot about, we have given the proof of this, that matter is made up of tiny particle. Now sugar is also made up of tiny particle of sugar. So sugar as a whole is made up of tiny crystal of many sugar particle, right? Also if we talk about salt, salt is also made up of tiny particles of salt. So it is also a mixture or the composition of the small crystal of salt, right? And then they add up together, it will become a salt composition, right? Now in this way, a substance consists of single type of particle, right? So what we conclude from these two examples, that sugar and salt, if we observe sugar and salt, then we can say that they are made up of same type of particle. All the crystal are of same compound, or they have same chemical formula, right? So from here we can define the matter which has single type of substances or single type of atom or particle is called as pure substances. So here the definition of pure substances, that we are asking that question, whether these substances are pure or not. So purity in the language of chemistry is what? Purity in the language of chemistry, that you are made up of single type of particle. So if any substance which is made up of single type of particle in the language of chemistry, all right, not in our daily life, because in our daily life we call many substances as pure, but chemically they are not pure. We will see the example as well. So first let's just understand what is pure substance. So pure substances are the substances which are made up of single type of particle. But on the other hand, we have seen the substances like soil, milk, right? Now we consider milk as pure, right? We used to say this to, we have heard this term, that pure milk or impure milk, adulteration of milk. So when somebody add water, it got adulteration of milk has happened. But if it is not, if water is not added, then it is a pure milk. Then can we say that in the language of chemistry that milk is pure? No, milk is not pure according to the chemical definition of the substances. Why? Because substances, there are matter like soil, milk and other rock. If we talk about only soil, then soil is made up of broken rocks, we know that, sand and clay and humus, right? Also if I talk about the milk, milk is also made of protein, carbohydrate, vitamins, right? So it is a mixture of these type of substances. So in the definition of pure substance, what we have understood, that pure substance is the only type of, is the substance which contains only same kind of atoms or molecules, right? But here in the definition of, according to composition of milk and soil, they are not the pure substances, because they are made up of different other substances. They are not containing same kind of particle or molecule. So the substances which are not made up of same type of particle or molecule are come under the category of impure. So in the language of chemistry, milk is not a pure substance, it's a impure, or we can say it's a mixture. So this is how we are going to define the matter into two classes. One is pure and another one is impure. So matter is classified into two categories now according to their chemical classification, chemical properties. So earlier we have discussed the classification of matter into different states. Here we are again seeing the classification, but now we are discussing about the nature, the chemical nature of the substances. So according to that, it is classified into pure and impure substances. Now, example, what are the examples? Sugar is a pure substance, common salt is a pure substance. On the other hand, impure, you can see the example, impure substances are soil and milk and many more, right? So these are the common example for pure and impure substances, right? But the story didn't end here. It has further categorization. So we need to understand in detail that how pure substance exist in different forms. Are they further classified or not? And what are the further classification? And similar for the impure substances, that how they are further classified. So we'll understand in detail that how pure and impure substances are further classified, right? So let's just see few more information about it. That it contains only one type of substance. We have understood that. Here it is made up of different, more than one type of substance. So whenever a substance is, whenever the composition of lies with the more substances, more than one type of particle or molecule, it will come under the category of impure substances, right? Also, we also call them mixture, right? When something is not pure, it is also known as mixture. It's a mixture, right? So impure substances can also be known as mixture. Let's understand the pure matter. Now pure matter are further classified as I have discussed. So what are the classification? Let's just understand this one by one, that what is the classification of pure matter. So if I talk about the pure substances, they are further classified into elements and compounds. And now we know that in our daily, in our not universe, on our earth, there are many elements which exist. How many elements we have discovered till now? 119 elements are discovered till now. So elements comes under the category of pure substances. Why? Because if you break any element, like let's take an example of gold element, right? Gold is element. If you break the gold, then you will get the particles of gold only. There will be no other particle until unless you haven't mixed any other type of substance, other type of mixing has not taken place. If you taken the pure gold, right? So when you break the pure gold, you will get the particle of gold only. So here we can analyze that elements are these pure substances. Why? Because they are made up of single type of atom. Similarly, for compound as well, compounds are made up of elements. So if elements are pure, then if they chemically bonded with each other, then this will also come under the category of pure substance, because now two different elements join, but they join chemically. Now they exist as a molecule. So I have said that pure substances are the substances which contain, here you can write the definition like that, which contains only single type of atoms, you can say. Either it has only single type of atom, or we can also define it as molecule, single type of molecule. Let's just take an example of water. So in a glass of water, only water molecule are present throughout this glass, right? So this is also a pure substance. So water comes under the category of pure substance because it contains only same kind of molecule. Here we have two different atoms, but they are joined together chemically in a fixed ratio, and in the whole container you just have the water molecule, same type of molecule. Then you can classify compound as the pure substance. So this is how we are defining pure substance. This is how we are further classifying pure substance as element and as compound. Now it has further categorization. Elements are further classified, we know about it. So let's just discuss about the pure substance in detail, or elements in detail. So if I talk about the elements, you have seen this, this is the iron rod, and this child is hammering the iron, what will happen? If you will hammer the iron with rod, you will get the iron particles only. So from here we can say that it contains only one kind of particle, that's why it is a pure substance. Then here we can define it as well. An element is a type of matter composed of only one. So here only one kind of substance where each smallest indivisible part of it has the same property. Okay, so if you will break the iron, you will get the pieces of iron, the individual particle of the iron having the same property, having the same type of atom. That's why elements are considered as pure substances. So this is clear. Now let's see the further categorization of elements. So substances which cannot be further, which can be so elements can be further divided into three categories, which are metal, non-metal, and metalloid. So you have heard these terms, and we have seen many metals, non-metal, and metalloids in our general life as well. The air we are breathing, it contains so many non-metals, right? The gases present in our atmosphere, they are combination of non-metal. So gases are generally non-metal, right? Here metals, we use many substances like utensils. You use this utensils. The lunch box is made up of steel or other type of metals. So we have seen the metals and non-metal in our daily life. And the third category is metalloid. We will discuss it about, they will discuss in this lecture only. So first let's just understand what are the properties of metal and non-metal, how you're going to differentiate between these two. So first understand the classification of element and properties of metals and non-metals, that what are the properties that metal and non-metal have. So first discuss about the metal, that metal are lustrous, means they have shine. So we have seen many metals like iron ore, when it is new, when it is not rusted, it shines a lot. Chromium, right? There are metals like mercury. Mercury also have a shine. The thermometer, you have seen that mercury goes up, it has a shine, right? So metal has a luster. Not all, but most of the metal have shiny surface. That's why we call them lustrous. All right. Then second, as you can see, these jewelry, they all are made up of some kind of metal and they are very shiny. So we used to wear many jewelry in our daily life as well. Why do we wear them? They all are very lustrous, very shiny, right? So jewelries are made up of metal, and we found out that metals are lustrous, right? Second property, sonorous. Sonorous means they are producing some sound when you hit them, right? So when it will make a ringing sound when we strike them, it is called the property of sonorous, right? The metals are sonorous. When you hit the iron rod with any kind of other substances, it will produce a sound. You will hear a sound. So this property is known as sonorous. Like the bells in the temples, so whenever this bell hit the bell, it will produce a sound, right? So from here we can say that metals are generally sonorous, not all. So here we should be very cautious about this word, that I am not talking about the all the metals, because there are few exceptions that you have to keep in mind. So here we are talking about generally they are sonorous. Not all the metal can produce sound, but generally they produce sound. Most of them are producing sound. Then third, they are ductile. What does it mean? It means that we can we can stretch them and convert into the form of wire. So from the metal we can make wire. So like copper wire that we use in our general life, like the electricity which is coming in our houses. So the wire, if you will peel off the covering of the wire, you will see the thin wire of the metals like copper metal or the other metal as well. So ductility means that metal can be drawn into thin wires form, right? So you can see these wires, this copper is coming out from the wire, the coating is of the rubber, so that it can be insulate, you will not get shock, otherwise it will be very dangerous. So we need to cover the wire because it conduct electricity. So they are ductile. Then malleable. Malleability means that they can convert it into thin sheets. So if you beat the metal, they will convert it into thin sheets. So this property is known as malleability. Now the question can be asked, the question which is mostly asked in your examination, that which of the metal is the most ductile metal. So here gold. Gold is the most ductile as well as most malleable. So it has both most ductile and malleable metal. So this question can be asked in your examination, that which one is most malleable and most ductile. So you can write the gold. Alright. So ductility and malleability understood. Next up we have, so this is how, even you can see the aluminium foil that you use to cover our lunch. Like, so your mom packed the lunch in the aluminium foil. It is also a metal and it converted into very thin sheet, right? So this is the property of malleability. Next, it is, they are the good conductor of heat and electricity. So we have seen that metal can conduct electricity because we are making the wire out of it, and what that wire do, it will conduct electricity from one place to another place. So they are good conductor of heat and electricity. So like they allow heat and electricity to pass through them very easily. They are good conductor of electricity, but again not all. And what question can be asked, that which one of the following, or which one is the best conductor of heat and electricity? So for that we have a name of the element known as silver. So you have heard the name silver, Ag. Ag is the symbol, and for gold we have a symbol as Au. So silver is the best conductor of heat and electricity. Other metal will also conduct the heat and electricity, but it is the best. Okay. Now second, the cooking utensils, you know that water boilers etc are used to made up of copper and aluminum metals. So why do we do that? Why utensils are made up of these metal? Because they are good conductor of electricity or heat. So whenever you want to cook the food, you use this utensil, then heat will get conduct through it and your food will get cooked or boiled. So that's why we use the utensils of the made up of metal, because they are good conductor of heat. Also we sometimes we use particular type of utensil which will work on the induction, which is a electric cooker, right? Electric gas. So they will work there because they can conduct heat and electricity through it. Then next property, these are the kind of utensils which are made up of metals. Then metals are generally hard. So iron, copper, aluminium, these are the hard metal. But again, the question can be asked from the exception, that which metal is not hard, right? So they are sodium, lithium and potassium. So they are generally hard, but there are few metal which can be cut by knife. So let me raise it and then you will see that there are few metals which can be cut by knife. So you have to remember the name of these metal, which is sodium. First one is sodium and the second one is potassium. I hope this is clear to everyone. These are the general property of metal, that how, what are the general property and what are the exception from these property. So exception question are very important, because they will ask with these are the tricky thing, there are only few example of it. That's why exception question will come in your examination. So you need to remember these exception of the property. The next property is that they have strong and have high tensile strength. That if you tensile strength means you cannot stretch the metal, right? They are not stretchable, they are not elastic. So they have very high tensile strength. You cannot stretch them, you cannot pull them, and they will change their shape. If you know that about iron cannot be stretched out and will not change its shape, right? So iron metal is used in the construction of bridges, railway lines, vehicles and chains. So iron is used to make these heavy kind of construction. Why? Because its tensile strength is very high. It can take the load of very heavy objects. Like if a train is passing through the railway tracks. So it has a lot of weight, but still it does not break. The railway lines does not break because iron has very high, it is very strong, very hard, and have a very high tensile strength. It will not break. It can, bear the load of these heavy objects like bridges as well. Bridges can also take the load of heavier objects. The trucks are passing through the bridges, but still they do not break until unless there is no problem, rusting has not taken place, and there are many years formed that bridge is formed by. So that's why until unless some exception or some fault is not there, the iron is having a good or a very high tensile strength. That's why it is used in these heavy construction. Even in our in even if we construct houses, there as well they will use iron rods, to make the pillars and everything, to take the load of the floors. So here it can hold large weight without breaking. That's why metals having a high tensile strength. So you can see the object which are made up of iron only, and taking the, or they can hold the large weight on itself. Then generally they are solid at room temperature. So again, here you have to remember this, that generally they are solid. So metal can exist in the form of solid. Few of the metal are also exist in the form of liquid. So generally they are solid at room temperature, but there is an exception about mercury. So mercury, Hg, right, this is the symbol of mercury. Mercury is an element which do not exist in solid state at liquid at room temperature. That's why we use it in thermometer, because it's a good conductor of heat. So whenever it will measure the temperature of yours, it will rise up in the thermometer, right? So why? Because it is liquid at the room temperature only. So we have this one exception. Also there are two other metal which has very low melting point, which will convert into liquid state very easily. If you keep them on your palm, they will convert into liquid state. So what are they? Gallium. So gallium and cesium are the two substances which you will put on your palm, will convert into liquid state immediately. But they are also solid at room temperature. So at room temperature only, if we are talking about the room temperature only, so at room temperature only mercury is liquid. Okay, other than other metals. So only mercury is liquid at room temperature, and there are two other metal which can also exist in liquid state, but it happen above the room temperature or on the temperature of your palm. So your body has little more temperature than the room temperature or in your hand. So whenever you put gallium on the hand, it will quickly melt and convert into liquid state. So if they will ask about the question that write the name of the metal which exist in liquid state at room temperature, then answer will be mercury. And if they will ask that what are the metal which can be converted into liquid state or which melts on palm, then it will be gallium and cesium. All right. So you need to be very precautious, because many students mistaken here that they also write the name of gallium and cesium here, that they are also liquid at the room temperature. So your answer will be wrong. You need to be cautious that they are not liquid at room temperature, but they will convert immediately when you will put them in on your palm. So palm has little higher temperature than room temperature. Okay, so let's just write it somewhere, note down this point, that you have to be cautious about this thing. And then exception mercury we have studied. So these are the, again, the last property is that they have high density. So we know that metals are generally solids. Solids have high density. The molecules are very compactly packed. That's why they are having high density. So many molecules are present in a small space. That's why they have high density. Because of their compact arrangement, because particles are very close to each other. That's why they having the high density. But again, exception can be here. The soft metal like sodium and potassium, they are soft metal, they can be cut, so they do not have a rigid shape, they are not very hard. That's why they have low density. right? So exception can come here, but generally metals are having high density. Exception, see, they have mentioned this exception, sodium and potassium, they have low densities because they are soft metal. So these are the property of metals. This is how you are going to classify any element as metal. If they are showing any of the property out of these property, then they are classified as metal, right? So you go through the property and let me know if any property is not clear to all of you. You can comment in the chat box and let me know where you are facing the problem. Otherwise, these are a very well known property. We have studied them from our very from the 6th class or 7th class. We studied all the properties of metals and non-metals. So you might have clear with this, but if you have any problem, you let me know. So these are the character or the property of metal. Now let's just understand the properties of non-metal, that how we are going to classify any element as non-metal. So unlike the metal, the non-metal are not lustrous, they do not have shine, so generally they do not have any luster. So this is like iodine, you can see it looks like this, it's in black color, so it does not have any particular shine, right? No, sorry, not about the iodine, so still have shine, but the metals like sulfur, it does not have any shine. So generally non-metals are not having any shine except iodine. All right, they are dull in appearance. Then non-sonorous, they do not produce any sound, so they do not making any ringing sound when we strike them. So from here we can say that non-metals are not sonorous, like, right? Next, not ductile as well, we cannot make wire out of the non-metal, they are not converted into wire form. Non-metal cannot be drawn into wire form, but here I can tell you one exception, that carbon can be converted into carbon fibers. So we have seen that even in our houses as well, we use the internet fiber, right? So there carbon can be converted into thin wire form, that we know as carbon fiber. So here can be one exception, that mostly they are non-ductile, they are not converting into wire form, but carbon can be converted into fiber form, it will be converted into thin wire form, that's why that is known as carbon fiber. So this is one exception. They are not malleable, we are not making any thin sheet of non-metal, so they are non-malleable, cannot be converted into thin sheet. Then bad conductor of heat and electricity, so they do not conduct, or they are very bad, they are bad conductor means they do not pass electricity and heat through them. But again it has few exception. What? A graphite. So graphite in the form graphite is the form of carbon is what? A non-metal, right? But it can conduct electricity, it is a good conductor of electricity, and we use graphite in many experiment of electrolysis. So in electrolysis we generally use electrodes, and electrodes are made up of graphite, which is which contains carbon atom, and carbon being a non-metal, so here this is one exception. So carbon in the form of graphite can conduct electricity. So it has particular reason because of its structure. So it has a particular type of structure, because of that it can conduct electricity, right? So it is a good conductor of electricity. Then generally soft. So non-metal are generally what? Non-metal are generally soft, but again it has an exception as diamond. So diamond is made up of carbon, but here the carbon atom is strongly bonded with other carbon atom, and because of that strong bond, the carbon carbon bond, it make a tetrahedral type of structure, a 3D tetrahedral type of structure, which is very strong. That's why it become very hard. So even if we know that diamond is the hardest natural substance, so naturally hardest substance which exists in our on our earth is diamond, and it is made up of carbon only. So exception is diamond, allotropic form of carbon, it's an allotrope of carbon. the hardest natural substance known. So here is one exception. So you need to keep these things in mind. Exception questions are very important. Mostly questions are asked on these particular information only. Right? Now you have seen the diamond. Also in shiny surface as well, you can write that we have discussed this property that non-metal are not lustrous, but here diamond can also be the exception of it, that it also has some luster. So have low tensile strength, they can break easily. That's why we do not use any non-metal in the making of bridges or any kind of substance. So it cannot hold large weight without breaking. That's why we do not prefer to make bridges or the high strength heavy object with non-metal. So they are generally made up of metals only. Then non-metal may be solid, liquid or gases at room temperature. So non-metal can exist in all three states: solid, liquid and gas. On the other hand, metal only exists generally, all of them, mostly of them are existing in solid form and few of them are existing in liquid form. No metal is in the form of gaseous state. But here we have all three states: solid like sulfur, right? And also phosphorus is also in the form of solid. Liquid, bromine, bromine gas, Br2. So bromine, not gas, bromine exists in liquid state. And gases, so we know that H2, N2, Cl2, the O2. All right, so they exist in gaseous state. So metal, non-metal can exist in all three states: solid, liquid and gas, and these are the example. So this is bromine. Bromine can exist in liquid state. Sulfur and phosphorus can exist in solid state, and these or other gases can exist in gaseous state. So this is how they exist in all three states of matter. Bromine is the only non-metal that exists in liquid state. We know that, right? So here it looks like. So it is in the liquid form only. Then carbon, sulfur and some chlorine exist in gaseous state. So here carbon also come in this category. It also exists in the solid state. And chlorine gas, oxygen gas, nitrogen gas, hydrogen gas, they all are existing in gaseous state, right? Next up we have that they have low melting and boiling point. So it is correct, because most of them are existing in gaseous state. So gas have molecule very far away from each other. That's why they are very less dense. So because of the less density, because molecules do not have that strong molecular force between them. No, they have very weak intermolecular force acting between the molecule. That's why they will melt easily and they will also boil easily. They will break their bond easily. So generally we say that non-metal have low melting and boiling point. On the other hand, if we talk about the metal, they generally have strong boiling and melting point, right? But here again we have one exception, that graphite being a non-metal has a very high melting point. Also diamond also having a high melting point. So graphite and diamond, you can write diamond here as well. So graphite and diamond, both of them have high melting point near to this. So they have very high temperature. That's why they come under the exceptional category. Next up we have, they have low densities. We have discussed it already, that being in a, because most of the metals are non-metal are existing in gaseous state. That's why they are very less dense. The particles are very far away from each other. So at a particular, in a particular volume, mass is very less. That's why density is also very less. Now, if we conclude the difference between metals and non-metal, we can say that here that metal are ductile and malleable. On the other hand, they are neither malleable nor ductile. So non-metal are brittle. So they are what? Brittle means they can easily break into pieces, right? Then here they are good conductor of electricity and heat, but they are bad conductor of heat and electricity, except the few exception case, right? So if we not considering the exception here, we are just seeing the overall point here. So overall they are good conductor of heat and electricity, and overall they are bad conductor of heat and electricity. Then they are lustrous but they are not lustrous. Here they generally exist in the solid state, but they can exist in solid, liquid and gaseous state. Then they have high tensile strength but they do not have high tensile strength. Sonorous, but here they are not sonorous. So these are the general difference between metals and non-metal, and this is how you can classify any element as metal and non-metal based on these properties. So let's just see the example of it. uh, like if a substance having high tensile strength and exists in solid state, so in which category you will put that element in? So you can see that the substances which have high tensile strength and exist in solid state, they will consider as metal. On the other hand, if I say that element having the low density and exist in gaseous state, so in which category we should put in? So we should put those type of element in the category of non-metal, because they generally have less density. Also they exist, most of them exist in the gaseous state. So this is how, if they will if the question will come like this, they have mentioned few property, then you can classify the element into metal and non-metal category. So I hope this is clear to everyone. You can go through the property and let me know if any problem you guys are facing. I'll check the comment.
Voice is clearly.
All right. So no doubt has been asked by you all. So I think we should move forward then. Now we understand the metals and non-metals, that how we are going to classify between metals and non-metals. Now there was a third category known as metalloids. So how do we classify any element into the category of metalloids? So let's just understand what metalloids are. So metalloids are the substances which have common character to metal and non-metal. Means these substances having few properties of metal and few properties of non-metal. So that's why we put them in the third category known as metalloids. Now which elements come under the category of metalloids? So arsenic comes under the category of metalloid. Silicon also come under the category of metalloid, and then we have germanium that comes under the category of metalloid, and etc. Now here we can discuss the name of all the metalloids, because in total we have 7 metalloids. So total number of metalloids are 7. What are they? You have seen the name of 3 of them: arsenic, silicon, germanium. Other one is boron, right? Polonium, tellurium. You can write the name, you can note down this and take a screenshot, right? And one more is antimony. All right, if you want to see the symbol, it has B, it has PO, it has TE, and it has SB. So these are the other 4 metalloid which have the common character of metals and non-metals. So somewhere they have the character of both type of elements like metals and non-metals. So that's why we come to the conclusion to make a third category as metalloids, right? So here, like if we talk about the silicon, what character it has? It is a good conductor of metals, like metals. Also it has low melting point like non-metals. So it has the character of both. That's why we classify silicon as the metalloid. Understood? So very easy topic or easy classification, that the substances or the element which having the character of both metal and non-metal are known as metalloids. How they are used? They are used in semiconductor for making electronic chips. So we know that electronic chips are used in many computer devices or in our mobile phones or electric devices. So they are used to make those devices, and they are used as a semiconductor, right? So this is the application of metalloids, and these are the example of metalloid. So definition, example, and the application. Now all three things are clear for metalloid. So this is how we are going to define elements into three categories. So I hope all the categories of element is clear now, that pure substances are classified into elements and compound, and elements are further classified into metals, non-metals, and metalloid. Now let's come to the other category of pure substance, which was compound. So as I told you, compound, because they made up of elements, that's why they also come under the category of pure substances, because by the chemical combination of two or more elements, compounds are formed. So how we are going to define that? Like water, you can see the example of water. So water is made up of two different elements, hydrogen and oxygen. So by the combination, by the chemical combination of these two elements, water is formed, a compound is formed. That's why it come under the category of pure substances. Then common salt, NaCl, made up of two type of elements, right? And they are chemically combined with each other. Here as well, CuSO4, copper sulfate, it is made up of copper, sulfur, and oxygen, chemically bonded with each other. That's why we call these type of substance as compound. Now by the definition, we can say that a compound is a substance made up of two or more type of elements chemically combined in a fixed proportion. You have to focus on these keywords, that they are chemically combined also in a fixed proportion. There should be a fixed ratio of their masses, and it can be further subdivided into simpler substance only by the chemical means, only by the chemical method. If you want to break down NaCl into Na and chlorine atom, right? So you have to apply some chemical method, you have to break the bonds. So chemical method should be applied, not because of any physical method they can be separated. So the substances made up of two or more type of element chemically combined in a fixed ratio are known as compound, and compound can further be divided into subparticle, but only by the chemical methods, not the physical method, right? So this is the difference between elements and compound, right? And we have seen many elements here, many compounds here. So elements of compounds are bonded with imaginary force of attraction. So here Na and Cl, they both are bonded with a electrostatic force, because we know that sodium is a positive type of ion and chlorine is a negative type of ion. If you don't know, then I will let you know. I will explain in the further chapter that how it become positive ion and negative ion. So it's just for your reference. All right, so for your reference, sodium is a positive ion and chlorine is a negative ion. Now we know that positive negative attracts each other, so there will be an electrostatic force which is binding these two atoms together, and hence they bonded with each other with an imaginary force and become a compound. So this is how compounds are formed, right? Then number of atom of an element in a compound are always fixed. So there will NaCl will always be having one sodium atom and one chlorine atom. If it will change, the compound will change. So the number of atom will always fix. Then that means the mass or the ratio or the proportion in which we are taking an atom is always going to be fixed, right? So this is going to be fixed. Then with the help of some chemical reaction, we can separate them also. So this is the in general definition for the compound, that this is how you're going to define a compound. Now properties of compound. So what are the properties of compound? So first property of compound is that they can be further subdivided into simpler substance by only chemicals means, right? So we have understood this point. In second point, we can say that compounds can be represented by using molecular formula. So there is a particular molecular formula by which we can present a compound. Like for water, we write H2O. For salt, we write NaCl. For copper sulfate, we write a formula as CuSO4. For sulfuric acid, we use a formula, molecular formula as H2SO4. So these are the particular molecular formula by which we can represent a compound, right? Then compound has totally new property than its original substances. So if you observe the property of the compound, then you will find out that they have completely different, because here chemical change has taken place, and we have understood that whenever chemical change take place, new property will be formed. So the compound will be having entirely different property than its original constituent. So from which it is made up of, it will having a total different property. So like hydrogen, how hydrogen is made up of? It is made up by the combination of hydrogen gas and oxygen gas, and then you will get water here, right? So if you observe the property of H2, so H2 gas is combustible and catches fire. This is a high inflammatory substance. It has a very high calorific value, right? So hydrogen gas is combustible and catches fire, and oxygen or O2 is a supporter of combustion. It will support and you know help in the combustion of any substances. But on the other hand, water, the water which is formed by the chemical composition of or the chemical reaction of H2 and O2, it has entirely different property. It will not catch fire. Instead, it will extinguish the fire. So it is used in the extinguishing the fire. So now from here you can relate this, you can have this idea that it is going to have the entirely different property than its constituent, right? So these are few properties about the compound that the property they show. So this is a very important point. This can be asked. Also they cannot be separated by chemical any not this one, they cannot be separated by any chemical means, and they are combined in a fixed ratio. So this point you have to keep in your mind, that compounds are only formed when a fixed ratio of the masses of the element combined with each other chemically. Only then a compound is formed. Next, matter. Now we know matter as a pure substance classified into elements and compounds, and elements are further divided into metals, non-metal and metalloids, and compounds. We also know that we have different categories of compounds. Now on the other side we have impure matter. So impure matter can also be further classified. How? Like it is classified into elements and compound. Impure metal is known as mixtures, right? So impure metal is defined as mixture because here we do not have any fixed proportion, right? Elements or the substances can mix into any proportion in any amount, and they are also not chemically combining with each other. So from here we can say that impure impure substances are also known as mixture, or if you further classify them you will get two type of mixture. One is homogeneous type of mixture and another one is heterogeneous type of mixture, right? So mixture or impure substances are further classified into two categories, homogeneous and heterogeneous. We will understand them one by one. I hope this is clear that what are impure substances, which do not contain single type of atom or single type of molecule, and also are not chemically bonded in any fixed proportion. So if they do not having this properties or this character, they are classified as impure substances, or you can say mixture. So you can see this mixture, this bhel puri. So everybody, it is looking mouth watering right now. So how does it made up of? What compounds it contains? So it contains many compounds. Like you can see here, you can see different type of particles. So what is this? This is actually a mixture. Is this dish made up of same type of substances? No, we can clearly see that it is not made up of same type of substances, right? Then, so this kind of substance is known as what? We know that the compound or the substance is not compound. The substances which are not made up of same type of particles or molecule are known as mixture. So this is a mixture, or you can say this is an impure substance. So in language of chemistry, if same kind of particle are not there or the molecule are not there, it is known as impure matter. Okay? Now this, which is further divided as, so you can also say impure substances as mixture, right? How many ingredients do we have in this? We have many ingredients in this. More than one, right? We have more than one. You can clearly see that it has many type of substances which it contains. So all ingredient mixed in a fixed proportion? No, it is not there. There few substances are present in less amount and few substances are present in more amount. So they also are not in the fixed proportion. So from here we can clearly say that it does not have any fixed proportion. It does not have same type of particle or not made up of same kind of particle. Also there is no chemical reaction that has taken place. If you make bhel, there is no chemical reaction required to make the bhel puri, right? So from here we can conclude that these type of substances are known as impure, or we can say them mixture, right? So all the ingredients are mixed in any proportion, right? So from here you can write a definition for the mixture or compound, that a mixture is a substance which is obtained by mixing two or more substances in any proportion without any chemical reaction. So this is a major difference between compound or the pure substance and impure substance. There compounds are chemically bonded, having a fixed proportion, but they in the on the other hand they are totally opposite to it, not having and no, do not have any particular proportion, and also they are prepared by mixing two or more substances, not having the same kind of particle. So in today's lecture we have learned about the chemical classification of matter, that how matter can be classified into different categories on the basis of their chemical properties. So we know that now matter is divided into two categories, pure and impure substance. Now unlike our daily life, pure substances has a total different definition in the language of chemistry, which is that same type of element, same type of particle or molecule, if they are chemically bonded, then it is known as pure substances. Otherwise they come under the category of impure substances. I hope this topic has been thoroughly clear to all of you. Now you have to revise the video, revise the video and solve the question based on these topic. I will see you in my next lecture. So until then, you also have the class with Japneet sir. So enjoy your physics class after my class and study well. I will see you in my next class. Until then, take care, study hard. So bye bye everyone. See you in my next class.